Hello everyone. I hope you all had a great break. We're just going to jump in and do some collecting like terms today. So it's your title, your learning objective, and your date. It'd be really great if you could write this down in your exercise books as well. So, first of all, what do I mean by a like term? Let's say I've got 2a and I'm adding 2 to it, and then I'm adding another 2a to it. A like term is something where it's got an unknown, basically, and an unknown will be the letter that's the same as something else. So that one's got an a on the end, that one doesn't have an a on the end, and that one has an a on the end. So these are the like terms here, and you can collect them by adding them together in this case, because it's add. We've got 2 A's there, and we've got 2 A's there. That means in total, we're going to have 4 A's altogether. Can't forget about that plus 2. We can't add that 2 to the A's over here because it doesn't have a like term. It doesn't have an A on the end. So we would write that just as plus 2. Simple as that. What about if we had 2a again plus 2b minus a? Well, first step is we got to find or identify what the like terms are. In this case, we've got an a there, and we've got an a there, and then there's a b. That's not a like term to anything. We can't do anything to it. We can't add it to anything else. We can't take it away from anything else. So now what we have to do, we have to collect these like terms, these a's. We've got 2a, and we've got a minus a. 2a's take away 1a, which is what a is. It's just 1a. Then that leaves us with just a, right? 2 minus 1 is 1. 2a minus 1a is 1a. We can write that just as a. Can we do anything with this 2b? No, we can't. So we just put 2b on the end there, just like that. That's what collecting like terms is. These are some fairly straightforward ones here. We'll go on to do some harder ones now, I think. Let's say we've got AB and we're adding it to an A, we're adding 2 ABs, and then we've got 2A there. First step, you've got a question that says collect the like terms, simplify expressions by collecting like terms. You need to find what those like terms are. In this case, we've got AB and we've got AB there. These two are our first set of like terms in this case. We can't add an A to an AB. It has to be the same. We can only add ABs and ABs together, and we can only add A's and A's together. These two are our second set of like terms. So we've got 1 AB and we've got 2 AB. How many ABs do we have altogether? We have 3 ABs. Yeah? We've got 1 A there and we've got 2 A's there. How many A's do we have altogether? We're going to have 3 A's. Yeah? Fairly straightforward when you know how to do it. Let's do another one. Let's say we've got 3BC plus 2D minus 2BC minus D. First step, what do we do? I'd ask you a question and you would answer it, but can't do that. This is a recorded video. BC and BC. Those are our like terms right here. Yeah? We've got 3BC minus 2BC. How many BCs is that going to leave us? Just the 1 BC. And we don't really write ones. We will just write it as BC like that. Yeah? Next set of like terms is D there, and there's a D there. So we collect those like terms, right? We've got 2D, take away 1D. How many D's will that leave us? Just positive 1D. 1D left. Make sense? Good. Right, one more example, or a couple more examples really. Let's say we've got X, or we've got 2 X's, and we're adding it to 2x squared, and we've got 3 X's here, and we've got another 2x squared. Why not? What are our like terms in this case? Like terms have to be identical. They have to be exactly the same as something else. Well, that's not strictly true, but I'll talk about that in a second. In this case, they have to be the same, right? That's an x squared. Those are not like terms. That is just an x by itself. That is x times x, which is the same as x squared. So we can collect the single x's by themselves there, and we can collect the x squareds, can't we? So we've got 2x plus 3x. How many x's will that leave us there? 5 of them. We've got 2x squareds, and we've got 2x squareds there. We're adding them together. That's going to leave us with 4x squareds. Yeah? Fairly straightforward stuff. One more, and I'll let you get on with some of the questions that I've sat. Let's do, because I know that this is going to be one of the questions, 2BC plus 2CB plus 3BC plus 4CB. What are the like terms in this case? Now, this one's a bit of a tricky one, right? Because technically, CB is the same as BC. It's saying C times B. That's what it basically means when you put letters together like this. C times B and B times C. So let's work that out, right? So we've got C times B and B times C. Let's say C is 2 and B equals 3. You would do 2 times 3 and you would do 3 times 2. What's 2 times 3? That is 6. What's 3 times 2? 6. It's the same thing. So CB is the same as BC. You can just flip them around if you want to. You don't have to, or you can just identify that they are the same thing, right? CB is the same as BC. AB is the same as BA, right? So we can add all of these together now because we know that they're like terms. We've got 2 plus 2, that's 4, plus 3, that's 7, plus 4, that's 11. We've got 11BC. Or 11CB. It's the same thing. Right. I'll let you get on with some of the worksheet questions now. You should have all of the answers there too. So I want you to do as many as you can. I think a minimum of 7. A minimum of 7. And then I want you to mark your answers afterwards. I want us to be really confident on this because we're going to carry on doing some more algebra stuff. And I really like algebra. Right, see you later.